Here we are at the last question of the exam, problem 21. Let's see what it's about. We got a cylindrical barrel. It has a circular base of radius r, and the volume is V. Do you remember the formula for the volume of a cylinder? We're going to have to know that, I'm pretty sure. For a cylinder, the volume formula is pi r squared h, right? Area of base, which is pi r squared times the height. So note that the area of the base is pi r squared, yeah. The material for the top and bottom of the barrel costs $5 per square foot, but for the sides it's cheaper, only at 3. So we want to write a formula for the total cost C of the barrel in terms of R and V. Well, that's not too hard. Why don't we do our work down here? So we don't know any numbers here, really, do we? We just have a cylindrical barrel. The base is R. The volume is V. And we're not told the height, are we? Okay, so let's go down here. So like I said, well, it's always nice to draw a little diagram. So I'll try my best to draw a cylinder. The radius, we're told, is r. We're not told the height, but let's just introduce a letter for that anyways, v. H, and then capital V is going to be our volume. What's the formula for that? The volume is pi r squared, which is the area of the base, times the height. So now what are we asked to do here? Write down a formula for the cost. Okay, let's write down this information. We know that the top and bottom, it costs $5, and the sides cost $3. So we'll so the top and bottom, it's $5 per foot, or per square foot. And then for the sides, it's $3 per square foot. So let's write a formula for the cost. Total cost. So wouldn't you agree that the cost is going to be kind of split into two pieces? It's going to be the cost of the top. Well, let's say we'll split it into 3 components. The cost of the top, the cost of the bottom, and then the cost of the sides. The cost of the top is going to be the area of the top times the price per square foot of material. So the area of the top is pi r squared, but then we multiply by 5, right? Because the cost of per square foot is $5. The cost of the bottom, it's going to be exactly the same. The area of the bottom is a circle, pi r squared times 5. Now the cost of the sides, that'll be a little bit more interesting. Do you remember that the lateral area, if I have a cylinder, let me just do a little discussion over here quickly and then I'll erase it. Don't write this down. If I have a cylinder, let's say the cylinder is empty. There's no top or bottom. And I make a little cut here and unfold it. It comes out to be a rectangle, right? The height of the rectangle is the same as the height of the cylinder. How about this length, though? What is the length of that side? It's actually the circumference, isn't it? And the circumference, if you remember, in terms of r, the circumference is 2 pi r. So the area of this rectangle is going to be the product of those two, right? 2 pi r h. That's what we call the lateral area, or the outside area of a sphere. The lateral area of a sphere, the sides, in other words, the area is given by the formula 2 pi r h. That's something you're expected to know, but I just wanted to quickly explain it. So let's, in this part here, I would write 2 pi r h, and then times the cost of the sides, which is 3. So let's clean that up. That's 5 pi r squared plus another 5 pi r squared, which is just 10 pi r squared. And here we have 6 pi rh. Now notice our formula has an h in it, but if we look back here, we don't want there to be an h in there because they say that we want the formula for the cost in terms of r and v only. So, but that's not really a problem because if I look at this formula, I can solve for h, right? If I isolate for h here, I get v over pi r squared. So I think what I should do is in this formula down here, I should replace the h by v over pi r squared. Kind of weird, but that will achieve what I want. So in place of h, I write v over pi r squared. And now that can be simplified a little bit. This part stays fine. But over here, let's see, the pi's cancel. And one of the r's cancel. So it looks like on the top we have 6 pi, or 6v over r. And I think that's the formula we're looking for in this first part. So let's copy that. And throw that in this spot. Now what's the next thing? Assuming that v is constant, so the volume of this barrel does not change. So by the way, the derivative of v would be 0 then, right? Write down an equation relating r and v that will be satisfied when r is chosen to minimize c. Well, if we're asked to minimize c with respect to r, we should think of c as a function of r and then take its derivative, right? So this is a function of r. Remember, v is a constant, so it's just some number. So we have some number over r, and this is some number times r squared. So this is a function of r. So I think what we should do is, this is our function c of r. We're going to take its derivative and set it equal to 0. Let's do that down here. Whoops. 1 second. Okay. So v is a constant, like we're told, so that means that this is really a function of r. So let me emphasize that by writing c of r. And now let's find the derivative with respect to r. 10 pi comes out front, the derivative of r squared is just 2r. 6v is out front. The derivative of 1 over r is negative 1 over r squared. So there's my derivative. Why don't I clean that up? I get 20 pi r minus 6v over r squared. Now what I need to do is I need to solve the derivative equal to 0 to find those critical numbers, right? The minimum must occur at a critical number. So let's solve that derivative equal to 0 to get our candidate for that minimum. Why don't I bring this over here? I can think of this as over 1, and then I can cross multiply, right? 20 pi r times r squared is 20 pi r cubed. 6v times 1 is just 6v. And why don't I divide both sides by 20 pi? So r cubed is 6v over 20 pi. Divide both by 2. So it'd be 3v over 10 pi. And so r is the cube root of 3v over 10 pi. This is a capital V. Both of these are good. This is solving for r explicitly, but I think in the question it just said find a relationship. And in terms of a relationship, this is a little bit more nice to look at. Write an equation relating r and v. They didn't ask us to solve for r explicitly, so I might just write this for my answer. But to be on the safe side, I might be tempted to just in case the teacher is a little bit picky, I could write this as well. Both are the same. This one's a little bit nicer to look at, but this one explicitly solves for r. All right, good enough. If the height of the barrel is h feet, so now they're talking about the height, find the quotient a over r in this minimal cost configuration. Okay. Well, let's see here. H, we already saw that h is v over pi r squared, right? Like, I guess the first temptation would be to, well, let's work down here. I'm going to grab this because I think I'll need it. So we're looking what h over r can be. I'm just going to write this over here just in case we need it. So here we go. What is h over r? I think maybe our instinct would be to replace h by this quantity here, v over pi r squared. And then r, well, we could just leave r alone maybe. So it'd be v is equal to pi over r cubed. I think that's, is that all we need to do? 1 second here. It's kind of annoying to have to go up and down all the time. Sorry about that. Now this is kind of, I don't know what they really want here. Find the quotient h over r. Well, we found out one version of that down here, right? H over r can be thought of as v over pi r cubed. Why don't we go a little bit further with that, though? R cubed is 3v over 10 pi, right? Okay, there we go. That answer is going to be nice now because, you know, these v's cancel. These pi's cancel. And I'm left with 1 over 3 over 10, which is 10 over 3. So that kind of worked out nice there. We don't want to give, you know, back here, if we would have gave our answer of h over r being v over pi r cubed, we wouldn't get full marks. We have to use this answer somehow as well, right? And I did that, and then we saw all this nice canceling happened. So it's 10 over 3 for that one. And that completes this exam. So it wasn't too bad. I hope you found it okay.